Greatest common factor, GCF. Another very important thing to identify and calculate in a set of two or more numbers is the greatest common factor, GCF. It represents the greatest number by which both original numbers are divided. For example, GCF of 8 and 12 is 4 because both 8 and 12 are divisible by 4. Although these two numbers are divisible by 2 as well, we are interested in the greatest divisor, factor. We can use the tabular method again, the same used to calculate the LCM, but this time we consider only the prime factors that divide all numbers simultaneously. Then, the greatest common factor, GCF, is calculated by multiplying these common prime factors. Example 1. Calculate the least common multiple, LCM, and greatest common factor, GCF, of 48 and 72. Solution 1. We use the tabular method to find both LCM and GCF. The common factors are circled and then we multiply them to find the GCF. Thus, we have the following on screen. The LCM of 48 and 72 therefore is shown in the following on screen. The GCF of 48 and 72, only the circled factors, therefore is shown in the following on screen. We can extend this method to more than two numbers, as we did for LCM. Example 2. Calculate the LCM and GCF of 64, 80 and 120. Solution 2. Again, we use the tabular method for finding both LCM and GCF simultaneously. We have the following shown on screen. Hence, LCM, 64, 80, 120, equals 26 times 3 times 5 is equal to 64 times 3 times 5 is equal to 960, and GCF, 64, 80, 120, equals 23 equals 8. Remark. If one number is a multiple of another, their LCM is the biggest number while their GCF is the smallest one. For example, LCM, 4, 12, equals 12 and GCF, 4, 12, equals 4. The concept of greatest common factor is also very useful in practice. We have the following example to illustrate this point. Example 3. A 56 meter by 40 meter rectangular field has to be surrounded by wire fence. To make the fence stable, we must fix vertical poles to the ground and tie the fence to them. What is the minimum number of poles required if they must be equidistant from each other? Solution 3. Using the minimum number of poles means placing them at the largest possible distance from each other. Since poles have the same distance from each other, we must find the greatest common factor of the two dimensions, i.e. of 40 and 56, which represents the distance between poles. We have the following shown on screen. Thus, we have GCF, 40, 56, equals 23 equals 8. This means the poles must be 8 meters away from each other. Therefore, since the field's perimeter, i.e. its total length, is P equals 2 times 40 meters plus 2 times 56 meters equals 80 meters plus 112 meters, equals 192 meters, we obtain for the minimum number of poles required shown in the following on screen. That is all for lesson 1.5.7, and the end of tutorial 1.5. To continue this chapter please watch 1.6, the visibility rules. Thank you for watching, make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.